Hello everyone, this is my submission for the Astro 255 project on the New Horizons spacecraft. So let's just begin. A little bit of background on the spacecraft. Um, Voyager 1 had the option of making a Pluto flyby after it made the flyby with Saturn in 1980s, but it did not because it instead decided make a flyby of Titan, which was much more interesting scientifically at that point and also a lower risk target. But NASA was still interested in sending a probe to Pluto, and in 1989 it began dedicated studies to explore those possibilities. And those studies were led by Dr. Alan Stern. Just yesterday, I asked him on Twitter what his favorite thing that he learned from being a part of this mission was, and he said, and I quote, how it inspired people all over the world. So he seems like a pretty nice guy. Anyway, in 2001, it was selected to be the first mission of NASA's New Frontiers program, and its main mission objectives were to characterize the global geology and morphology of Pluto and Charon, map the surface composition of those two bodies, and also characterize the neutral atmosphere of Pluto and its escape rate. These three aspects of any body will help us understand how these formed and also how they're going to evolve. Right, sending a spacecraft 39.5 AU away is going to come with its challenges, as you can imagine, and the most prominent ones were the weight limit and the power and heat management that you need at that distance. So since they wanted to get the probe to Pluto within a decade, they had a 480 kg limit on the spacecraft, and of that weight, 50 kg was limited to science instruments. Yeah, and they had to make use of power from other sources apart from the sun, and this meant that the total wattage was limited to 200 watts, and of that 200 watts, only 20 watts was for science instruments. To put that in perspective, 20 watts is how much wattage your laptop uses in sleep mode. All right, let's look at the spacecraft and see how the team overcame those challenges. So this is a 3D model of the spacecraft, and as you can see on the this is the race side, and this is where the antenna is attached, and this right here is the radioisotope thermal generator, which just makes use of plutonium decay to produce electrical energy. And the main thing to note here is the structure of the spacecraft. It's kind of in a triangular shape, and most of its important instruments seems to be on these triangular sides. And I'll talk a bit about that later. And you can also notice this gold colored layering. That's a multi insulating layer, and that makes sure that you don't that makes sure that you don't lose power unnecessarily out of the spacecraft and recycle that to other parts of the spacecraft. Right. A bit on the propulsion and the rotation of the spacecraft. So these are the three coordinates system on which the spacecraft operates. The y-axis points away from the antenna, the x-axis goes through the RTG, and the z-axis is just as defined in a right-handed coordinate system. So the spacecraft spends most of its time spinning about this y-axis here, and as you can imagine, that should be pointed towards Earth, right? And you have all these science instruments around it. So what the spacecraft does is, as it's pointing towards Earth, it rotates the instruments as it rotates the whole body itself. So the instruments depend on the rotation of the entire body to make these slewing measurements and to find the right targets. So the instruments themselves don't have any reaction wheels or any other mechanism to point at targets, and this is because reaction wheels and they add too much weight to the spacecraft. So if you want to save weight, these are the sacrifices you have to make. And all the bunch of arrows here are just the groups of thrusters that the spacecraft had all around. All right, let's look at the instruments on New Horizons. So the first set of instruments is called Percy. It's a remote sensing suite, and it's comprised of three instruments: MBIC, Lisa, and Alice. MBIC is a four-color CCD imager, and Lisa is an IR spectrometer, and Alice is a UV spectrometer. MBIC and Lisa are combined into Ralph, and these wavelengths that you see here are chosen because based on ground-based observations of Pluto that were made earlier. To get measurements of Pluto's atmosphere and its interaction with the solar wind, these two instruments, SWAP and PEPSI, were built. SWAP measures solar particles up to 1.5 kiloelectron volts, and PEPSI measures ions and electrons up to a higher energy of 5 mega electron volts. And it is the distinction between the energies is important here because you expect Pluto's atmosphere to eject higher energy particles than what the sun's sending in. So PEPSI is going to make more measurements about the ions and the electrons ejected from Pluto's atmosphere. The other instruments are LORI, which is a visible CCD imager, and radio science experiment, and dust collector, which was built by students. It was part of NASA's outreach program, and this is an image of all the instruments put together. One interesting thing to notice here is the power generator, the RTG, is as far away as possible from all the instruments, especially LORI, because it has a CCD and it needs to be chilled to super low temperatures. All right. All right. Got the instruments done. Now let's look at how it journeyed to the Pluto Insurance System. First off, the launch. The launch of the spacecraft was done on 19th January 2006 from the Cape Canaveral base launch site, and the launch site is really important here. Cape Canaveral is almost at the equator of Earth, and launching a spacecraft tangentially from the Earth's equator makes full use of Earth's orbital velocity and allows you to send the spacecraft at the fastest speed possible. The spacecraft was launched into space using the Atlas V rocket. It had 5 boosters attached to it, highest ever. It also had 3 stages of burns, also the highest ever. And all of this allowed the New Horizons spacecraft to be launched at a speed of 16.3 kilometers per second with respect to Earth, and that is the fastest that a spacecraft has ever been sent into space. Simply put, it was yeeted into space as hard as possible. Before the spacecraft got to Jupiter, it made a quick Jupiter flyby. And the reason for this is, as you can imagine, to get a gravity assist from Jupiter, because the spacecraft itself doesn't have enough fuel because of the weight limit to get to Pluto entirely based on its fuel. So it had to make use of gravity assist or free delta V coupons, and this increased the spacecraft speed by 4 kilometers per second. and reduced the flight time by about 3 or 4 years. It was also a good dress rehearsal for Pluto flyby in terms of testing the science instruments and making necessary calibrations. A bit on the science at Jupiter, it observed atmospheric conditions, structure, and composition. It imaged faint ring systems and also the Great Red Spot. One interesting science that it did was when it was moving through Jupiter's magnetosphere, it detected bubbles of plasma, which are expected to be from Io. These are the stunning pictures that New Horizons took of Jupiter. You can see all the layers of Jupiter's atmosphere. This is the Great Red Spot, and this is Titan with the plumes, and these are the four moons. These are some of the ring systems that it detected. Fascinating. All right. After Jupiter, the spacecraft had to travel another 8 years to get to Pluto, and it spent most of this time in hibernation mode, only sending a red or a green signal back to Earth, and it made some annual checkouts on science instruments every 2 months or so, or every year. So I'm gonna shut up for a little and let you guys take this in. Whoa, right? Whoops. All right, we've arrived. After 9.5 years from launch, we're finally at Pluto. This is a quick comparison between the two images, the left one taken by Hubble and the right one by New Horizons. Who knew getting 30 AU close to the planet would produce better images? Anyways, we all love pretty pictures, but the reason we paid $700 billion on this spacecraft is for the instruments and for the science. So let's see what the instruments were doing at Pluto. So Alice studied the composition of Pluto's atmosphere by examining the emissions that it was emitting, and also from measurements it did when it was in occultation with Pluto. I'll talk about that in a little while. Swap and website measured the higher atmosphere and its effects on solar winds. The two Ralph instruments, MBIG and LISA, obtained global maps in IR and in four other different wavelengths. So this made a comprehensive mapping of Pluto's surface. And LORRI, the visible imager, made maps of select regions with an amazing resolution of 50 meters per pixel. These regions were selected beforehand, I think, and maybe they were also corrected while the spacecraft was close to Jupiter. Anyway, the gravitational effects that Pluto made on the spacecraft were detected through changes in its Doppler shift. All right, a bit on occultations. It's basically like a mini solar eclipse. The it occurs when the object that you're interested in, say Pluto, is in between you and your direct line of sight to Sun. Right? And the reason occultations are important is because studying the interaction of Sun's light with the planet's atmosphere gives you a lot of information, like what is it made of, how is it layered throughout, and other aspects. It also helps you determine the radius. And one method of doing that is the following. So we know that most of the sun's light is blocked by Pluto's surface, right? And right below Pluto's surface, you don't expect to see any sunlight or very little of it. And right above Pluto's surface, you expect a lot of sunlight. a bit of it is absorbed with the atmosphere, but still the change is what is important here. The gradient between the flux right below the surface and above the surface has to be the highest anywhere in this picture. And by knowing that fact, we know that the highest gradient points are where the surface of Pluto is. So we know where the surface is. To find the radius, we need to know where the center is. For that, we just guess. We select a bunch of radius points and you measure the distance from the center to the surface. And whichever center gives you a constant value of radius, because we are assuming the planet to be surface and spherical and turns out to be too. So whichever center gives you a constant value for radius is your best guess of the center. Uh, the results that New Horizons made after its flyby to Pluto. It determined the radius from the method that I mentioned earlier, and also a bunch of other ones to be these two numbers. And Charon's radius turned out to be half of Pluto's. Very little oblateness was detected on both of these bodies. The radius determination method that I mentioned earlier could also give you how oblate it is by measuring how much the tiny variation radiations are. Critically, the densities of the two planets were were within 10% of each other, and this has implications on their formation and their ways of formation. No bulges were detected either on Charon or Pluto. Mm, This is this was kind of unexpected. The composition of Pluto was found to be 70% rock and 30% ice. Ice here just stands for methane, nitrogen, and other stuff. Uh, and Charon's composition was 55% rock and 45% ice. So the leading theory before New Horizons launch was that these two objects were formed through a collision by a body on Pluto, and the debris that was emitted in this collision coalesced to form Charon, right? But this theory predicted uh, a much less icier Pluto than what was observed, and a much less rockier Charon than what was observed. And the reason it's predicted a much less icier, much less icier Pluto was that because you would expect when the collision to happen, uh, Pluto's outer layer to be mostly ice, right? And you would expect the ice from this layer to be destroyed from the collision, and the same goes with Charon. Anyway, surface features. There's a lot of stuff going on here. There's so many interesting things here, but I'll only restrict uh, to talk about only the Tombow region and the Sputnik Platina. So Sputnik Platina was the smoothest surface that they found on Pluto. It was mostly found to be made of nitrogen and methane, and as you can see, there's almost no craters here. Yeah, they also found a lot of mountains all around Pluto of 2 to 3 kilometers height, and these mountains are expected to be some water rock bodies, and the layers on these mountains are expected to be of methane, nitrogen, and carbon monoxide because those were the highest abundant materials that were found around those areas. Yeah, various levels of cratering, but no craters, no visible craters from this resolution on Sputnik Platinum or SP. The radiance factor, which is just a measure of the reflected versus, which is just a ratio of reflected flux versus incident flux, varies from 0.1 to 0.7, as you can see here. And it's found to be the lowest in its equatorial regions and highest in in the polar cap and SP. This is the widest range apart from a moon of Jupiter. From knowing the vibrational absorptions of methane and carbon monoxide happening at these different wavelengths, the abundance of these two materials were found. CH4's abundance was found to be about 0.25%, and this was a bit lower than expected. And its distribution was pretty wide, but most of it was observed in the northern polar cap and SP. So when you first look at Pluto, let me go back to the picture. First thing you notice is these varying colors, right? What causes these colors? And the reason for that is these organic compounds called tholins. These are expected to be they form when ultraviolet light reacts with methane and nitrogen, and since this is abundant on Pluto, it makes sense that these cause the changing colors. All right. This is just a map of this is a graph. Yeah, this is a map of CH4 abundance and the atmosphere. The surface pressure was found to be about 10 microbar. That's 10 to the negative 6 times less than Earth's. And the layers of atmospheric gases were as shown. There's also an atmospheric haze that was found extending from about 150 kilometers above Pluto's surface, and these are thought to be tiny solar particles wiggling around just above Pluto's surface. Yeah, as I mentioned, atmospheric abundance of methane was about 0.25%. The escape rates of nitrogen CH4 were found to be 10 to the 23 and 10 to the 25. This number is way lower than what people expected, and it's still a little puzzling for people. These numbers were found by assuming an exobase existing at around 2,800 kilometers. These are the temperature and pressure graphs. The different line styles show different sets of measurements. One of them was taken when Pluto was, or when the spacecraft was moving towards Pluto, and the other one when the spacecraft was moving away from Pluto. And these are the graphs of the abundances. These spikes can be, you can just think of them as absorption lines. And this graph here shows the abundance in these units and the altitude at which these change. All right, there was much more science than that done by New Horizons, but I just restrict my presentation to talk about just Pluto. But there's a lot of interesting stuff regarding the satellites of Pluto, and I encourage you to look up on it. All right, what are the major conclusions that you can make out of these results? So Pluto is much more diverse geologically and also in its composition throughout the surface, right? And no ablateness was also detected. So this means that when Pluto and Charon, right after Pluto and Charon were formed, Pluto had to have a lower spin rate, because if it had a high spin rate, differential rotation would cause the body to be not spherical at all. And the location of Sputnik Planum hints at a possibility of subsurface ocean. And there's a lot going behind that statement. Basically, it's that SP is at a location is at a very specific location, and if you assume that that specific location is because it has a higher mass right below its surface, then you can explain that location pretty well. So how can you have a higher mass right below a smooth surface? And well, an ocean is probable. It also gives us new insights into the collisional model of formation of the Pluto and Charon system. Since these two bodies have similar densities, this implies that they were not completely differentiated when they were formed. Because if Pluto was differentiated when it was formed, you would see only the outer layer of the differentiated Pluto on Charon, because that's how Charon was formed. That's how Charon forms in this model. But this is not the case. The densities are very similar. So this, along with the restrictions on volatileness that New Horizons gives, makes corrections to the collisional model that we have for the moment. And the low escape rate of N2 and the colder upper atmosphere temperature is still puzzling, and there's a lot of research going on about that. Okay, my idea is that the temperature in the upper atmosphere is lower because there's less CH4 and less greenhouse effect. I have no idea if that's right, but let me know what you think of that. All right, post Pluto. The mission was extended up till 2021 after making such a successful flyby of Pluto. So after it was headed into the Kuiper belt, and the search and the team started searching for a Kuiper belt object to make a flyby for. And the criterion for the search was the object had to be within this range of diameters and within 55 AU. Within 55 AU because it had only about 33 kg of propellant left, and it's not possible to make it to an object beyond this distance. So a bunch of ground-based observations were made to try and figure out a good KBO for New Horizons to make a flyby of, but they did not produce anything good. So the Hubble Space Telescope was called upon, and it found three potential targets, which one of which is shown here. The PD1 potential target one was named MU69 first, and then Ultima Thule, and finally it's now called Arrow. And this target was chosen because of its 100% probability of making it to that target given the fuel budget. The main objectives of the flyby were to map the physical characteristics and surface composition of Arrow and search for any moonlets or rings. All right, this is a quick video on Arrow's approach. I can't get enough of these approach videos. All right, brief summary of science from this flyby. So ultimately, Arrow is made of two binary lobes. The longer one, called Ultima, is 21 kilometers long, and Thule is 15.4 kilometers long. This object was detected earlier by the Hubble Space Telescope, and they expected the object to be more of a snowman or a shmoo type of object, but turns out to be than much more flattened than spherical. And the reason for flattening is thought to be because of high spin rates when the body was still deformable, and centrifugal forces causing the body to flatten out. Its surface is quite interesting. There's a lot of hills, trough pits, bright and dark areas, and it was also found that Arrow had varying colors, and this colors was due to the presence of tholins, the organic compounds that cause the varying colors in Pluto. Formation. So how was this object formed? We don't know, but our best guess at the moment is that when in the early solar system, there's a lot of small icy bodies just chaotically moving around and interacting with each other. And a group of these icy bodies coalesce and form bigger, larger rocks as seen here. And if you want to get these larger rocks to interact and touch each other, you have to have some sort of transfer of angular momentum, and this can be done by interactions with smaller bodies. And as the two bodies lose their angular momentum slowly, they come they spiral inward towards each other and form one combined object. Uh, this theory of formation, if right, lends a lot of credence to the core accretion model, which says that most planets form through accretion of this type. So this is pretty exciting. Right. What's next? So it's safe to say, with all the discoveries and insights that Horizons made, that it was an exceedingly successful mission, and it definitely broadened our horizons of knowledge in terms of planetary science and planetary formation and evolution. Right now, it's about 44 AU away from the sun, and it's still traveling in the Kuiper belt object, and it's looking for KBOs to make distant observations or even flybys of. There's still a lot of data just from AeroCard that hasn't been downlinked yet, and so yeah, there's going to be a lot of research coming out in the next couple of years. So look out for that. Right. Closing remarks. Thank you all for watching. If you've made it until here, I think this video is about 30 minutes long. Oh, and thank you all for making your videos. It was amazing learning from all of these different spacecrafts. And thanks to Dr. Dong for an amazing semester of planetary science. And I hope all of you are safe and healthy. Bye.